Hey there, friends and neighbors. I'm going to show you now how to create a complete example of a results section for a single categorical variable with two categories. So we're going to be using a single sample z-test, or equivalently a chi-square test, for one proportion. And I'm going to be using R Commander and EasyR to do that. Now these are the components that go into your typical results section and are required for the introductory stats class. You always need a descriptive statistics section. You always need a graph, which is sort of an extension of the descriptives. Then you need your inferential stats, and those are going to involve statement of HO, H1, and alpha, your assumption check, and if you violate the assumptions for a class project, you really just acknowledge that and move on. But in real life, it's a problem, and you need to fix it in some way. That requires more advanced training. Then comes the confidence interval, if appropriate, the test statistic, degrees of freedom, if appropriate, and p-value. Then decision about HO. Do I reject it or fail to reject it? An interpretation of the confidence interval. And then finally, the whole thing needs to be interpreted into plain English for the research context. That's what we do. So let's go ahead and get started. I've imported a data set. It's a CSV file just downloaded from the data for this class page. And they're called donors. And they've got the hypothesis that 70% of the population is a blood donor. Okay. So to run these analysis, we go statistical analysis, discrete variables. All categorical variables with the EasyR plugin are under the discrete variables heading. Okay. And then we go one sample proportion test. Then choose the variable which is donor, choose chi-square test, turn off the exact test, and turn off the continuity correction. Now theirs is, I think they said at least 70%, which means the alternative is that it is less than. Okay, and then the 70%, we have to choose that for our null hypothesized proportion. So the alternative is that it is less than 0.7. That's what it means to be at least 70%. Then we click OK. Okay. And this basically gives us all the results we need. If you scroll up, you'll see the 18 failures and 22 successes of people who are donors. The sample proportion is right here at 0.55. Since 18 plus 22 equals 40, that tells us that their N was 40. Okay. So that's the descriptive statistics. We want p hat. The sample proportion is given to be 0.55, that's 55%. N is 40. And that's it. For this simple project, that's all you need for the descriptive stats. Then we need a graph. You go graphs and tables. A bar graph or a pie chart are the only things that are appropriate. Click on donor. I like to draw it in color, show graphs side by side, group side by side, and compare proportion in each group. Those are things I like. Then you click OK, and here's your graph. Okay, now if you have a Windows or Mac, you can just right-click and copy this image and just save it. I use Linux myself, and so I'm going to do it a little bit differently. I'm going to paste the image, and then I'm going to select it and cut it out and paste it into my paper. So that's how I'm going to do it. Cut. Okay. Okay. Done with that. Done with that. Go back to my paper and right click. Paste special. I'm going to try that. Nope. Paste. There it is. I'm going to anchor it as text. So right click on it. Anchor as character. Cancel, make it a little bit smaller, just make it fit better into the paper, and there we go. We're going to cut it and paste it where I want it. And there we go. So I've got the graph in there. Descriptive statistics, graph. Next comes the inferential statistics. And with their research, they said they hypothesized that so-called at most, or at least 70%. Well, at least is a statement of equality that says HO it is equal to, P, the population proportion, is greater than or equal to 0.7. The alternative is that P is less than 0.7. Alpha, no reason to change it, just choose 0.05, that's the typical alpha. The assumption check. So for a single sample z-test, we assume, first off, you always assume independence, and that's achieved by random sampling. But then we also assume that n times p is at least 5, and n times 1 minus p, sometimes written as q, is at least 5. And for this, you use the hypothesized proportion, 0.7. So to check this, I'm going to say 40, which is n, times 0.7 equals, I actually don't know what that is, so I'm going to compute it, equals 40 times 0.7. 28 equals 40 times 0.3. 48 and 12. 48. 40 times 0.3 equals 12. And that is, of course, the assumption is satisfied because they're both at least 5. Okay, so you got your H1 alpha, you got your assumption check, and now we're going to go do the actual tests, which we've already done it. So I'm going to just go copy it from R. Here it is. Here's your chi-square test statistic, 1 degree of freedom, and your p-value of 0.019. Just copy that and paste it. The 95% confidence interval, you will notice it has 0 on one side. That's because they, with their hypothesis, it's a left tail test, which means we're saying that it's at most 0.67. Okay, and so let's go ahead and interpret this. First off, the p-value is less than alpha, or I should say less than or equal to alpha, so we reject HO. And we are 95% confident that the true proportion, population, of blood donors is at most 0.67, so 67% or less is what I'm confident of. Okay, and they hypothesized it was 70% or less, and that's, or I'm sorry, 70% or more. That's the null hypothesis. So in plain English, we say evidence supports the claim that less than 70% are donors in the population. Specifically, we are 95% confident that at most 67% are donors. And that's it. That's a complete example of a results section for a single categorical variable with two groups. You've got your descriptive stats, your graph, your HO-H1 alpha, your assumption check, test statistic and confidence interval and degrees of freedom and p-value, decision about HO, and interpretation into plain old garden variety English. And that's it.